Welcome to Standard 9th Algebra, Chapter 2 Real Numbers, Part 2. Here we will be learning properties of irrational numbers. Now, properties of irrational numbers are addition or subtraction of a rational number with irrational number is irrational number. Multiplication or division of a non-zero rational number with irrational number is also an irrational number. Addition, subtraction, multiplication and division of two irrational numbers can be either a rational number or an irrational number. Square root of a negative real number is not a real number. Now, we will be doing practice set 2.2 question number 3 onwards. Here, the question is represent the numbers root 5 and root 10 on a number line. The first question root 5 we will show on the number line. Draw a number line and take a point A after 2 units. Draw AB perpendicular to the number line such that AB is equal to 1 unit. That means OA is perpendicular to AB. Therefore, in triangle OAB, we have angle OAB is equal to 90 degree. Now, using Pythagoras theorem, OB square is equal to OA square plus AB square. Now, when we substitute the values of OA and AB, we get OB square is equal to 2 square plus 1 square. Opening the brackets, we get OB square is equal to 4 plus 1 and that is equal to 5. Taking square root both sides, we get OB is equal to root of 5 units. With O as center and radius OB, draw an arc to intersect the number line at C. That means on the number line to the right side, we get OC is equal to root 5. That is our root 5 on the number line. Let us do question number 2 of question number 3, that is represent root 10 on a number line. Draw a number line and from origin O we take 3 units and name it as P. At P we have to make a perpendicular PR such that PR is equal to 1 unit. Join OR. Now, in triangle OPR, that is angle OPR is equal to 90 degree. So, using the Pythagoras theorem, OR square is equal to OP square plus PR square. Putting the value of OP square, that is 3 square plus 1 square, we get 9 plus 1. So, OR square is equal to 10. Taking square root, we get OR is equal to root 10 units. So, with O as center and radius OR, if you make an circle or arc cutting the number line, OQ is equal to root 10. The arc will join the line at Q. Therefore, OQ is equal to root 10. Now we will be doing question number 4. Write any 3 rational numbers between two numbers given below. The first question is 0.3 and minus 0.5. Now we know that 0.3 can be written as 0.30 and minus 0.5 can be written as minus 0.50. So between 0.30 and minus 0.50 we can have innumerable numbers like this. 0.30 will be greater than 0.29, will be greater than 0.28, will be greater than 0.27 and so on, will be greater than 0.10, will be greater than minus 0.10, will be greater than minus 0.30, will be greater than minus 0.50. So we can take any three rational numbers between 0.30 and minus 0.50. So we have taken the three rational numbers between 0.3 and minus 0.5 as minus 0.3, minus 0.1 and 0.1. There is an alternate method to find rational number between two rational numbers a and b. That is the midpoint of two rational numbers. That can be found out as a plus b upon 2. So the first number 0.3 plus 0 minus 0.5 upon 2. When we open the bracket, we get 0.3 minus 0.5 upon 2. We get it as minus 0.2 upon 2. So when we divide the number by 2, we get minus 0.1. Now the one number is 0.3 and the next number is 0.1. So we will find another number midpoint of now between 0.3 and minus 0.1. So that will be adding 0.3 and minus 0.1 and divide by 2. So we get it as 0.3 minus 0.1 upon 2. The numerator, when we solve it, we get 0.2 upon 2. So the answer is 0.1. So we have got two numbers, that is minus 0.1 and 0.1. So now we will take one number as minus 0.1 and the next number as minus 0.5. Add it and we divide by 2. So we get it as minus 0.1. When we open the bracket, it will be minus 0.5 divided by 2. So when we solve minus 0.1 and minus 0.5, we get minus 0.6. Dividing by 2, we get minus 0.3. So the three rational numbers between 0.3 and minus 0.5 are minus 0.3, minus 0.1 and 0.1. Second question is minus 2.3 and minus 2.33. So minus 2.3 can be written as minus 2.300 and minus 2.33 can be written as minus 2.330. So we know that now we will write it in descending order. Minus 2.300 greater than minus 2.301 greater than and so on minus 2.310 greater than so on minus 2.320 greater than minus 2.330. So we can take any three rational numbers. We have taken it as minus 2.310, minus 2.320 and minus 2.325 between minus 2.3 and minus 2.33. Second question, 5.2 and 5.3. So 5.2 can be written as 5.20, 5.3 can be written as 5.30. We know that between 5.2 and 5.3 there are lot of numbers. So we can write it as 5.20 is less than 5.21, less than 5.22, less than 5.23, less than and so on 5.30. Therefore, three rational numbers between 5.2 and 5.3 are 5.21, 5.22 and 5.23. The fourth question is minus 4.5 and minus 4.6. So minus 4.5 can be written as minus 4.50 and minus 4.6 can be written as minus 4.60. So we know that minus 4.5 is greater than minus 4.6. So minus 4.50 greater than minus 4.51 greater than minus 4.52 and so on greater than minus 4.55 greater than minus 4.60. Therefore, the three rational numbers between minus 4.5 and minus 4.6 are minus 4.51, minus 4.252 and minus 4.55. We will be learning about surds. What is surd? If n is an integer greater than 1 and if a is a positive real number and nth root of a is x, then it is written as x raised to power n is equal to a, or nth root of a is equal to x. If a is a positive rational number and nth root of a is x, and if x is an irrational number, then x is called a surd. That means an irrational number where nth root can be found is called surd. In a surd, nth root of a, the symbol root is called the radical sign, n is the order of surd, and a is called the radicand. In the surd, cube root of 7, 3 is the order and 7 is the radicand. Let us do practice set 2.3. Question number 1. State the order of surds given below. Cube root of 7. The order of the given surd is 3. 5 root 12. Here it is given as square root of 12. Therefore, the order of the given surd is 2. Fourth root of 10. The order of the given surd is 4. Square root of 39. The order of the given surd is 2. Cube root of 18. The order of given surd will be 3. Question number 2. State which of the following are surd and justify your answer. Cube root of 51. It is a surd because 51 is a positive rational number greater than 1 and cube root of 51 is irrational. That means we cannot find the cube root of 51, therefore it is a surd. Second question, fourth root of 16. It is not a surd because fourth root of 16 can be written as 16 raised to power 1 by 4 and 16 can be written as 2 raised to power 4. So 4 multiplied to 1 by 4, 4 and 4 will be cancelled. The answer will be 2, which is not an irrational number. Therefore, fourth root of 16 is not a surd. Third question, fifth root of 18. It is a surd because 18 is a positive rational number, 5 is a positive integer greater than 1 and fifth root of 81 is irrational. That means we cannot find the fifth root of 81. Therefore, it is a surd. Fourth question, root of 256. Square root of 256 can be found out. That is 16 raised to power 2 is 256. So 16 raised to power 2 raised to power 1 by 2 is equal to 16, which is not an irrational number. Therefore, square root of 256 is not a surd. Fifth question, cube root of 64. Again, cube root of 64, we can write 64 as 4 raised to power 3. Now 4 raised to power 3, when raised to power 1 by 3 is there, 3 and 1 by 3, 3 cancel, it will be cancelled. It is remaining with 4, which is not an irrational number. Therefore, 64 raised to power 1 by 3 is not a surd. Square root of 22 by 7. It is a surd because 22 by 7 is a positive rational number. 2 is a positive integer greater than 1. Therefore, square root of 22 by 7 is irrational. Therefore, it is a surd. Now, we will be doing comparing the questions. Root of 52 and 5 root 13. Root of 52 can be written as square root of 4 multiplied to 13. It can be further written simplified as square root of 4 multiplied to square root of 13. So square root of 4 will be 2 multiplied to root 13. Now here the order of 2 root 13 and 5 root 13 is same and the radicands are also same. So they are like surds. Second question, root of 68 and 5 root 3. Root of 68 is equal to square root of 4 multiplied to 17. Square root of 4 can be written as 2. So the answer of root 68 is 2 root 17. Now the next number is 5 root 3. Here the order of 2 root 17 and 5 root 3 is same. But their radicands are not same. Therefore, square root of 68 and 5 root 3 are unlike surds. That means the number which is inside the square root, here it is 17 and here it is 3. So the radicands are not same. Third question, 4 root 18 and 7 root 2. 4 root 18 can be written as 4 multiplied to square root of 9 into 2. Square root of 9 can be written as 3. So 4 into square root of 9 multiplied to 2, we get 4 into 3 into root 2. So it can be written as 12 root 2. The next number is 7 root 2. Here the order of 12 root 2 and 7 root 2 both are same and the radicands are also same. That means the number inside the root, here it is also 2 and here also it is 2. Therefore, both the numbers are like surds. Fourth question, 19 root 12 and 6 root 3. 19 root 12 can be written as 19 multiplied to square root of 4 multiplied to 3. So 4 square root of 4 can be written as 19 into 2 into root 3. So 19 into 2 is 38. We get the answer as 38 root 3. The next number is 6 root 3. So we will compare the order of both the numbers are square root. Both are same and the radicand which is inside is 3. So both are like surds. 5 root 2, 22 and 7 root 33. Here the order of 5 root 22 and 7 root 33, that is square root, both are same but the radicands are 22 and 33 which are not same. Therefore, 5 root 22 and 7 root 33 are unlike surds. Sixth question, 5 roots to 5 and root of 75. Root of 75 can be written as root of 25 into 3. So root of 25 can be further written as 5 root 3. Here the order of 5 root 3, 5 and 5 root 3 is same, but the radicands which are inside the square root are 5 and 3 which are not same. Therefore, 5 root 5 and root 75 are unlike surds. Thank you students.